Hello, in our last lesson we reviewed how to solve systems of inequalities. So today we're going to take it a step further and we're going to go over how to solve word problems that involve systems of inequalities. So I'm going to do one example up on the board. The problem that we are given is that Wasatch Academy wants to buy tickets to a Utah Jazz basketball game. So they have a budget of $600. Student tickets cost $25, and adult tickets cost $50. And then additionally, due to school rules, there must be at least one adult for every 6 students. So we want to create and graph a system of inequalities to represent the situation. So this probably seems like a lot of information that is thrown at us, and that's pretty true. But the one thing we know is that we're going to want to have 2 inequalities. So we're going to have inequality number 1, and we're going to have inequality number 2. So the first thing we want to do is we want to pick out what we call the constraints, which are kind of guidelines that tell us how to make our system of inequalities. And we're going to get our constraints from information in the problem. So the first piece of information that we're given is that Wasatch Academy wants to buy tickets to a Utah Jazz basketball game. The thing about that information, though, is it doesn't have any numbers. It's just kind of background information for the problem. So we're going to have to read further into the problem to find information that we're actually going to use in creating our system of inequalities. So we have that they have a budget of $600 and that student tickets cost $25 and adult tickets cost $50. So this is our first piece of information that we're going to use to create our first inequality. So I'm going to circle this, and I'm going to label it number 1. Because this is the information that's going to go into our first inequality. So the question is, how do we represent this information in an inequality? And that's a very good question. So we have student tickets and adult tickets. So a logical way to represent this information would be we can have A represent the number of adult tickets, and we can have S represent the number of student tickets. And there you see we have 2 variables. We have A, our number of adult tickets, and S, our number of student tickets. So if we want to put this into an inequality, we're going to have 600, which is going to be the total cost, is going to be greater than or equal to 25S plus 50A. And that's because we know the school can't spend more than $600, and each student ticket costs $25, and each adult ticket costs $50. So this equation represents our first constraint, which I have circled in blue here. So now we want to get the second piece of information to write our second inequality. So we have, additionally, due to school rules, there must be at least one adult for every 6 students. So this is piece of information number 2. So this one's going to be a little bit trickier to put into an equation. So there must be at least one adult for every 6 students. So that would mean that 6 S or 6A, because 6A is the number of adults, is greater than or equal to S, which represents the number of students. Because here, if we test out a couple values, if we have 6 students, for example, we would have 6A as our number of adults, and that would mean our number of adults would have to be greater than or equal to 1. Because if we solve for A, we would get A is less than or equal to 6 over 6, which is equal to 1. And that makes sense because if there are 6 students, in order to maintain the ratio, we need at least 1 adult. So I'm going to circle, put our 2 inequalities in a box. And so we've done part 1 of the problem, which is we have created a system of inequalities. Now the question is, how do we graph this? So to graph our system of inequalities, so we have 2 variables. We have the number of adult tickets and the number of student tickets. And we're just going to pick one to be the dependent variable and one to be the independent variable. And we're going to want to solve each equation so that we get it into slope-intercept form. So first, if we look at this equation, let's just decide to make S the number of student tickets our dependent variable. So we can start to solve that one by saying we're going to subtract 50A from each side. We get 600 minus 50A is greater than or equal to 25S. And then, if we divide each side by 25, so 600 divided by 25 is 24. So we would get 24 minus 2A is greater than or equal to S. And if we flip this, we would get S is less than or equal to negative 2A plus 24. So I'll box it again. Our second equation is already in this nice slope-intercept form. So I'll just flip it and write S is less than or equal to 6A. So now you see both of these inequalities are in slope-intercept form, so you can go ahead and graph them. So I'm going to graph the first one. I'm just going to do approximate graphs here, but our intercept is 24, and our slope is negative 2. So if y, which we will label as students, and x we can label as adults, and our graph is going to look something like that. And since the slope is negative 2, this intercept is going to be at 12. And we have S is less than or equal to negative 2A plus 24. So I'm going to shade in the area under the graph. So that's one inequality, and we can see that inequality represents the fact that the school has a budget of $600, student tickets cost $25, and adult tickets cost $50. But we also have this other piece of information, which we represented with this inequality. So we have S is less than or equal to 6A. So on that one, the y-intercept is going to be 0, and it's just going to be a pretty steep line that looks like this. And notice, just an aside, I'm only graphing this quadrant because this quadrant of the graph is the only area that we're really interested in, because we can't have a negative number of adults or a negative number of students. We have S is less than or equal to 6A. So again, I'm going to shade in the area under the curve. And the solution to our system of inequalities is the area that's shaded by both inequalities. So this triangle area here represents the area that satisfies both of these system of inequalities. So we have again, so the school can only buy so many tickets because it will run out of money. So that's where I run up against this blue boundary. But then we also have the fact that there has to be at least one adult for every 6 students, which is why, for example, we can't have 24 students and 0 adults. You can imagine that would be a pretty bad situation to have at the basketball game. But we could have, for example, 10 adults and 2 students, for example. That point would be over here. So hopefully this example will illuminate kind of how you can turn a pretty complex word problem into a system of inequalities. And that's about it.